Alright, this is Chapter 4, Section 2. So we did probability in the, we did mean, variance, standard deviation in the past. You're like, well, what's the difference here? Well, when we start doing probability distributions, each of the values or samples have a different probability of happening, right? So we did IQ and milligrams and things in the past. Each one of the samples that we did, right, had the same chance of actually happening. Each of these have a different chance. That's going to modify the mean, right? It's going to modify the variance, and it's going to modify the standard deviation, essentially, right? So the only other new concept is the concept of expected value. And what that value is varying. If we're talking about dollar amounts, the expected dollar amount you're supposed to win, or the expected outcome of the game, depends on the context. So the expected outcome, or E, is the mean, essentially, but you have to do it in context as to what it is. So let's do a very basic example first. So let's say we flip a coin 3 times. You can either get tails or heads. So how many heads do you get? So there's only 8 possibilities, obviously. This is our sample space up here. Come on, pen. It's going to fight me, I guess. What's it doing here? There we go. There's our sample space, right? So you can either get no heads, 1, 2, or 3. I don't know how you get more than 3. Because you're only flipping it 3 times, correct? So there's only one way to get no heads. There's only one way to get 3 heads. And there's 3 ways to get 2 heads and 3 ways to get 2 tails, correct? So 3 out of 8 and 3 out of 8. So we've proven that this is a probability distribution, correct? Because it adds up to 1. Each of the individuals are 0 to 1, and the variable itself is random. So therefore, this is a probability distribution. Okay, so if you look at the formulas at the top of the page, x times p of x would be 0 out of 8, right? Correct? 1 times 3/8 is 3/8, right? 2 times 3/8 is 6/8. And 3 times 1/8 is 3/8, right? So if I add these up, that's 6 and 6 for 12/8, right? So the only time you really want to simplify fractions is in this section when it has to do the distributions. It just makes it a little bit easier. Otherwise, the other sections are probability, not so much. So we get 3 halves, which is our mean, essentially. So the mean of this game is 3 halves, right? That's the form at the top of the page, which is also these formulas here. Okay, so our variance is next. So x is 0, x is 1, x is 2, and x is 3. Subtract, 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 right? So we put the x in. So mu is 5, right? This is our mu, all right? That's our mean. So 3 halves squared, 3 halves squared, 3 halves squared, 3 halves squared, right? Okay. All right, so the next thing we need to do is the probability, right? So the probabilities are right here. So 1/8, 3/8, 3/8, and 1/8, right? Okay, I'm going to do some basic fractional math now. Okay, so this is basically 0 minus 3 halves, so I square that, I get 9 fourths, right? 9 fourths times 1/8 will give me 9 30-seconds, correct? All right, so 1 is really 2 halves, minus 3 halves is 1 half, so I square it, I get 1/4 times 3/8. So that's what, 3 30-seconds? Correct? So 2 is really 4 halves, so 4 halves minus 3 halves is 1/4 half, so I square it, I get 1/4, right? Times 3/8 is 3 30-seconds. So let's see, that's what, 6 halves minus 3 halves is 3 halves. Square that, I get 9 fourths. So that's 9 30-seconds, right? So 9 and 3, 9 and 3, that's 12 and 12, so that's 24, right, 30-seconds. So you simplify that, you get 3/4, right? Okay, so 3/4 is my variance. So if I square root that, square root 3/4, I get my standard deviation, right? Which would be the square root of 3 over 2. So the last thing is expected value, right, which is the uppercase E. So what should I expect from this game? I should expect 1.5 heads. 1.5 heads, right? Because the mean is the expected value just in context, right? So how the hell do you get a half a head, right? Well, if you look at the sample space, right, there are 8 possibilities. So theoretically, if I did all 8 trials, I should probably get this, and it would average out to 1.5 heads. So what expected value is your expected outcome averaged out over time, essentially, if you did infinite or 8, wherever the case may be, right? So it's a theoretical, right, as to what should happen. But you shouldn't be doing this manually, right? This is a very small problem, so doing it manually is very doable and not that time consuming, but otherwise it's going to be very time consuming, and we don't want that, okay? All right, so don't be, so we want to do it in a spreadsheet, essentially, as far as calculating these. All right, so what we want to do here is the dice problem, right? So remember the 4 dice problem? So we're going to do the same thing, but now it's the sum of the dice, the die rolls. It should be dice rolls. Oh, well. The sum of the 4-sided dice, right? So if you remember the sample space that we did, that is right here, correct? The sum of the 4-sided dice, that's our sample space, and that's what we got, correct? So you can use the online Excel or the local one, doesn't really matter. We need Excel. Okay, so we need the, let's blow this up a little bit. All right, so we need the X, the sum there. We need the P of X here. We need the X times P of X here. We need X minus mu squared times P of X here, right? Oop, going the wrong way there. Okay, make that a little bit bigger. Okay, we'll highlight all those, yellow, middle amount, bold them, and box. Okay, so if we think about what were the possibilities when we did this, right? We get 2 through 8 with the possibilities, correct? So 2, 3, 4, 5, 6, 7, and 8, right? Because you get a 4 and a 4, you get an 8, you get a 1 and a 1, you get a 2 when you roll those 2 dice, correct? So what's the probability? It's 1/16 for this one, correct? And make sure you do the equals, right? So this one is equals 2/16, right? If you just type in, let's say you just typed in 1/16, right? 1/16, right? It doesn't know what to do. You're just typing in symbols, you know what I'm saying? Don't do that, right? And also make sure it's on number, right? And you can play around with it essentially, right? So equals 1/16, right? And you get your number, right? And then you get to play around with the decimals. So don't do that. You want to equate values, right? So you want to equate, right? This was 3/16, right? This one was 4/16. This one was 3/16. This one is 2/16. And this one is 1/16, right? Should have been symmetrical. What's the issue here? Ignore error. That's fine. Okay, so x times p of x, right? And I'm going to drag that down. Okay. Oh, we didn't verify this, so we do the sum and add all those up, right? So this is our totals, right? Total equals, right? And we'll shove that to the right. So that means it is probably a distribution, right? It is, right? And if we sum these ones up, okay, x times p of x, that is the mean, right? So that's correct. So we'll center those out, and I don't know what's nice here, orange. All right, that's the mean, right? Okay, so the next one, you get a little bit of work here, because it's x minus mu, which is the mean, right? That's the mean, to the second power, times p of x, which is right here, correct? The problem is, if I drag this down, it's not going to work, right? If I drag this down, not going to work, right? Because notice what happens when I drag this down. It's using this box down here, right? So it changed the C, because it's no longer this C9 anymore, right? Because I need to make sure I do $sign and $sign, right? Because the A and the B columns are going to change, right? They're going to go down, but this is 5 is not going to change. It's going to be 5 every single time. So now I go down, right? And I do the sum of all of those. Hopefully it works. And I get 2.5, right? So that is my variance, right? Variance. right? And we'll take those, I don't know what's a nice color, green, bold, and middle, right? And then we'll do standard deviation, right? And we'll do equals the square root of that answer there, right? And there's our standard deviation, correct? So we'll bold and blue and center. So those are our answers essentially, right? So that's a lot quicker way of doing it than trying to hand calculate, 100 different fractional operations where you're probably going to mess one up. Because all I have to do here essentially is x times p of x, drag it down, get my mean, right? X minus the mu, which I got from the previous answer, square it times the probability, drag it down, get the variance, right? So whether it's 5 things or 100 things, it's a lot quicker essentially, right? Okay, so for the okay, let's go back to the correct page here. All right, so the dice roll problem, we essentially did this in the spreadsheet, correct? And this is what we got, right? All right, so as a result, our mean was 5, right? Our variance was the 2.5, correct? And the square root of 2.5 here is essentially what we got. All right, so my expected value is 5 for the sum, right? That's what should happen, right? So like, what do you mean 5? Well, if I did this all 16 times, it should average out to 5. Sometimes it's more, sometimes it's less, but it's going to average out to 5, basically. That is the expected value of this game. All right, that's the end of this part.